This is the walkthrough video for PCTC 2021-2022 round 2 question 9 camera ID. Okay, so this question is quite difficult, but I really enjoy it because it requires a bit of extra thinking. So essentially, we're given this image in the form of text, and we want to look at this pattern, and then we're going to be given 5 more images, and we want to try and identify this pattern in the other 5 images, and then do some more maths and print out the answer. Okay, so I'll probably first detail the approach we're going to take. So what I want to do is essentially, this is the first example image that they give us. And what we're going to do is we're going to chop it down to only the pixels have a 1 on it, right? Because storing this entire 10 by 10 grid is kind of useless. Like we don't really care about the zeros. We only care about the ones, the places where the light is on. And so what I'm going to do is I'm going to chop this grid down into that 5 by 3 grid. And I'm going to do the same thing for every other input that we're given. So for the second input in this case, I'm going to chop down again this 10 by 10 input grid into only the grid that captures all of the lights. And also, for example, 3, I'm going to do something like that. And so you should get the idea by now, which is that I'm just going to kind of squash down our grid so that it encapsulates every light with the smallest x and y values possible. So like all of these grids have the smallest width and the smallest height possible while still holding all of the ones in our input. And let's just make this a bit clearer. Okay, so why am I going to do that? Well, this makes identifying a pattern extremely easy. So if example 1 was our first input, the image that we want to find that pattern for in the other images, well then that's easy, right? Because we've already kind of squashed this down into a grid that only contains the ones, we can just directly compare the grids, right? Is that grid the same as that grid? And if they are, then both inputs 1 and 2 have the same pattern. And is that equal to this? Well, no, they're not. And so input 3 does not have the same pattern as input 1. And this is really is the key benefit of squashing down our 10 by 10 grid into a grid that just captures all of the ones. It means that it doesn't matter where in our grid our pattern is placed, right? Our pattern could be placed there or could be placed there. The only thing that matters is the pattern itself. And that's the benefit of this approach. So now we just have to implement this. Now the very first thing, as always, is to take in our inputs. So let's call this image 1. It's going to be input for I in range 10. And so all we're doing is we're just taking in a string 10 times, which is going to represent the first image. And now we want to do this squashing process. And how are we going to do this? Well, we want to look for essentially the first x coordinate at which there is a 1. And in this case, it's going to be this. So we want to look for that coordinate. We also want to look for the last x coordinate where there's a 1. And that's going to be here. And we want to do the same thing for the y as well. We want to look for the first y coordinate where there's a 1. And the last y coordinate where there is a 1. And then you can see that all we need to do is just take in that central overlap rectangle. And we can do the same thing with the rest of our inputs and just apply exactly the same algorithm just with each of our inputs. And for each of them, we'll then get this box that represents all of our ones. Okay, so let's look for that. How are we going to look for that? Well, I'm going to say ones is going to be a list, and I'm going to use the list comprehension, and I'm going to say I for I in range 10 if 1 in image 1i. Okay, so that might be a lot to unpack, but essentially what we're doing is we're going through every line in our input image, and we're basically saying if there is a 1 in that line, so this is that specific line, and we're saying if there's a 1 in that line, then what we want to do, well, we want to add the index of that line to our list called ones. And if you're not familiar with this type of like one line for loop and if statement, then I'll just very quickly throw up a non-one line version and you can kind of see how it compares. But again, just do whatever feels good for you. Yeah, so these 4 lines are equivalent to this 1 line. They do exactly the same thing. And so just choose whichever one you're most comfortable with. I'm just going to stick to this one. Yeah, this will also work. Actually, I'm probably not going to stick to that one. I will stick to that one. Yeah, ignore me. But yeah, I'll just kind of save this code in case people want to look at that. Okay, so now ones is a list that contains the index of every line that contains a 1 on it. And so that means that 1, 0 is the first line that contains a 1, and 1's -1 is the last line that contains a 1. And so what we can do at this point is we can trim image 1 to only contain those lines. So we're going to say image 1 is equal to itself. We're going to slice it, and we want to start the slice at the first index in our ones list, and we want to end the slice at the final index in our ones list +1, just because Python always kind of counts to your number -1, and so we just need to +1 to compensate. And so what we've done here is we've now cut our image such that the y coordinates now trimmed out, right? So what we've done is if 1 was our input, we've now just got this blue segment here, and that's what we've turned our input into. And so now we just need to do the same thing, but for the x values. And the way to do that, there's actually a pretty sneaky way. So we've already written the code to do this, right? And I don't want to have to bother thinking through the logic to figure out how we're going to do this for the x values. So what I'm going to do is I'm just going to transpose our list. So the word is transpose. I'm just going to transpose our list. And the way we do that is going to be by saying image 1 is just going to be equal to a list zip and unpack itself. So I'm not going to explain how this line works. You can do that if you're curious about it. But essentially this line will transpose a 2D array or a 2D list. And what that means is you're just flipping the x and y coordinates. That's all transposing means. You're just flipping the x and y coordinates. And what that means is we can literally just copy paste this code from above, the exact same code, and the exact same code is going to work, except that whilst this ran on the y coordinates, this is now going to run on the x coordinates. The exact same code, right? And just because I've now flipped the image, I want to flip it back to how it was originally. And so I'm just going to transpose it again. So transposing it once flips the x and y. Transpose it again, flips the x and y again. So you get back to your original image or your original list. And so yeah, these are the 6 lines of code that will effectively take in our input, draw these blue lines, and then extract only the middle rectangle that we want. And as we discussed, this is going to be very useful for all of our inputs. And so we should probably just turn this into a function. And so let's very quickly do that now. So let's do def and let's just call it extract. And let's input a list. And let's change all of these variables to list. You know what we can actually do is, because this is literally just the same code, like these 2 blocks of code I've highlighted are exactly the same thing. We might as well just put all of this in a for loop. So let's just do this thing twice. And that kind of just cuts out the amount of variables that we have to rename. Honestly, we can just bother leaving the rest, but out of good practice, let's not do that. List, let's change that to list. Ones, I think ones is a valid variable name. So if you've done that twice, we can then return our list. Awesome. So let's now run this function on image 1, which is our input, and we can reassign image 1 to whatever the output of this function is. Awesome. So now we've chopped down our first image, and we've got this function that will chop down any other image that we put into it. And so now we can take in our next 5 inputs, and we can do basically the same thing. So we're just going to say image n, just because n is going to be like either 1, 2, 3, or 5. 1, 2, 3, 4, or 5. And that's just going to be input for I in range 10, for I in range 10. And so this is basically just the same line as line 1, where we're just taking in our next image. And we're going to run this image through our extract function. And we're now going to compare to see if the image that we've just obtained and extracted the pattern from is equal to image 1, then there is a match. And so we want to add let's create a matches variable. And so we want to add 1 to our matches variable. And yeah, that's pretty much it. This code is going to run 5 times for each of our 5 input images. And at this point, we now just want to print off the final answer, which I believe is the amount of matches multiplied by the amount of ones in your original line. So the amount of ones in our original image, that's going to be count ones is going to be equal to so let's say that is equal to 0, and let's do for line in image 1, we want to do count.ones is equal to itself plus line.count1. So how many ones are in that line? And then, as we said earlier, we just want to print off the amount of ones in that first image multiplied by the amount of matches that we had. And hopefully this gets us 10 out of 10. Nice. Yeah, so this question is a bit complicated. This code is a bit complicated. I think the core to solving this problem is to understand this algorithm that we'd selected. And once you understand that, then you can implement it however you want. I thought this was a pretty neat implementation. But yeah, you do you. Hopefully you learned some cool Python. Hopefully you racked your brain and really enjoyed this exercise.